am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about the overview of RISC process. So before going to the detailed discussion about RISC process, so some of the subtopics we will cover in this session is characteristics of RISC process and also the characteristics of CISC process. So based on these characteristics, next we will see the differences between RISC and CISC process, and so how this RISC and CISC process are designed, that is based on the Harvard and Neumann architecture. So we are going to see how the Harvard and Von-Neumann architectures will be, and with respect to their characteristics, we are going to discuss about the advantages and disadvantages of RISC and CISC process and some design issues in the RISC process. So all these are the subtopics we are going to cover in this session. Next. So here basically the CPU, that is Central Processing Unit, it operates based on the design of instruction set architecture. So here the design of instruction set architecture is classified into different types. So the microprocessor design will be as per different categories, like it may be either RISC processor, CISC processor, or some special purpose process. So in this session, we are going to learn about this RISC process and CISC process. We are going to see the characteristics of RISC and CISC. Next, we will see the advantages and disadvantages, and then we will go for the differences. Next. So here, based on the architecture, so we have different types of processors. So some of the processes comes under RISC. So here RISC stands for Reduced Instruction Set Computing, and another category is CISC. So here CISC stands for Complex Instruction Set Computing. Okay. So here the name itself says reduced instruction set. That means here the instruction set will be simple, but whereas here CISC, complex instruction set. So in this case the instruction set will be complicated. So here we will go to detailed discussion about this RISC and CISC. So first we will see about RISC. What is RISC? So RISC stands for here Reduced Instruction Set Computer. Okay. So the characteristics here we are going to learn regarding the number of clock cycles required, how the instructions will be, how about the code in order to write the program, number of lines, and how they are accessing the memory in order to store, how about the addressing modes. So all these are some of the characteristics we have to discuss under this RISC and CISC. So in the RISC architecture, we are having simple instruction set. That means the instruction set will be very simple, easily understandable. So since the instruction set is very simple, in order to decode that particular instruction is also very simple. And next characteristics is it reduces the execution time. That means the time required to execute any instruction, it will take less amount of time because the instruction is very simple. Now, so each instruction requires one clock cycle. That means in order to execute any instruction, it requires only one clock cycle. So in the reduced instruction set computer, the number of clock cycles required to execute an instruction will be fixed. So here it requires only one clock cycle to execute instruction. So basically, in order to execute any instruction, the three basic steps are fetching, decoding and executing. So here the three things can be done within one clock cycle only. And so here execution time is uniform. That means however the type of instruction is, in order to execute that particular instruction, the execution time will be same. So whatever the instruction is, to execute that instruction, the execution time required will be uniform. So all the instructions requires same amount of time to execute. And so here we have studied that it is having simple instruction set. So in order to execute the program, so for example, if you want to write any simple 8-bit addition program, so if you are considering any instructions under RISC, in order to write the same program, we have to write by using more number of lines. So here more number of lines will be there in the program to execute one operation. So why it consists of more number of lines means, since the instruction set is very simple, in order to perform, for example, 8-bit operation, you cannot use directly one instruction. We have to use the instructions, different instructions, like first it has to load the instruction, then the operation should be performed, then we have to go for storing the result. So in order to write these many number of instructions, automatically the code consists of more number of lines. And more RAM is needed to store the instructions. That means here more amount of memory is required to store the instructions, because to execute simple operation, we have to use more number of instructions. So the length of the program is high. So that is why in order to store all that instructions, we need to have more amount of RAM. And some more features are, so in this case, RISC, the compiler has to work more to convert high-level language instructions into machine code. That means here the compiler has to do more work. Generally, what is the purpose of compiler? The compiler is going to convert this high-level language instructions into machine code. So in the RISC processors, we are writing more number of lines in the program. So the compiler has to do more amount of work to convert high-level language instructions into machine code. And next feature is this RISC processors supports various types of data formats. And so it utilizes simple addressing modes. So here it is going to use simple addressing modes. And so it consists of large number of registers. So here basically consisting of large number of registers means especially general purpose registers will be more in number. So since in the RISC processors, general purpose registers are more in number, in order to store the variables, we can use here registers. No need to access the memory unnecessarily. So since the number of registers are more, so by using all these registers that are available, we can make the memory free. And so these are all the features of RISC processors. Here, these RISC processors, going through all these features, they will be used in some devices like Apple iPod, smartphones and tablets. So in all these applications, the RISC processors will be used. Now, so some of the RISC processors are, so PowerPC 601, 604, 615 and 620. So all these PowerPC processors comes under this RISC process. And next we have DEC Alpha. So all these are the processors that comes under RISC processors. And also we have MIPS RISC processor. So this number processor comes under RISC processor. So all these are some of the examples of RISC process where all those features are involved. So here this is also one of the RISC processor, that is PA RISC HP 7100LC. And so here this is the RISC architecture. So in the RISC architecture, here this is the main unit. That means this unit is a hardwired control unit where all the control information, the operation that should be performed like instructions. So all these things will be present in this hardwired control unit. So here this hardwired control unit can access this data path and instruction cache. So here in this RISC architecture, if you observe, the data path, that is data path unit, and this instruction cache unit, both are separate. So both these units will be accessed by this hardwired control unit. So this data path, all the data information and all will be present in this data cache. So here this instruction cache and data cache, both will be stored in the main memory. So ultimately in the RISC architecture, so here in the RISC architectures, the instruction and the data both will be resided in the main memory. So in order to access this instruction and data, we have to access, the controller has to access the entire main memory. So this is the RISC architecture. So here RISC architecture and CISC architectures, the main RISC and CISC processors, they are designed based on the basic two architectures. One is hardware architecture and Von-Neumann architecture. So in one architecture, the program and data will be resided in the same unit, whereas in the another architecture, the program will be resided in another unit, whereas data will be resided separately. So based on that Von-Neumann and hardware architecture, how the program and data are resided. So here comes the RISC and CISC process. So here in this RISC architecture, the instruction, that is nothing but program, and the data, both of them are resided in the same memory. Now, so coming to the characteristics of RISC. So here, the characteristics of RISC, small and limited number of instructions. So here the name itself says RISC. It stands for Reduced Instruction Set Computing. So it says that the instruction set is very simple and less number of instructions are available. And the instruction operation is also very simple. Now, so in order to increase the speed and performance of RISC, a limited number of frequently used instructions are executed. So since here the number of instructions are very limited, so during its execution, so it is very simple to execute that particular instruction. Because in the RISC architecture, any instruction can be executed by using only one clock cycle. So that is why the speed of operation will be high. So the performance of RISC process will be increased. And another characteristics of RISC architecture, RISC processors are hardwired control units. So just we have seen the architecture of RISC processor. So there the important unit that we have observed in the architecture is hardwired control unit. So that hardwired control unit is the main unit that is going to access the instruction cache and data path. So by using the hardwired control unit, the entire operation will be done like producing the control signals, because here inside this hardwired control units only, the logic circuitry, instructions, so all these things will be present. So this hardwired control unit is the main control unit in order to access the program and data. So hardwired control units are having fixed logic circuits for controlling, and also it consists of signal generation, input and output signals like read and write, and interpretation of instruction set. And so RISC uses hardwired control units in its design structure to execute an instruction. So this is the hardwired control unit, and it also leads to better performance and faster processing, but the implementation is not flexible. So here the implementation is not flexible means because the hardwired control unit has to access the program memory and data memory separately. Now, some more characteristics of RISC are high performance with decreased power. So it can produce high performance. So though it produces high performance, the power that is going to use is very less because it is having some features. So RISC process achieve high throughput, but it is going to use less power. How means this is achieved, that means high throughput with less power can be achieved when processor's resources are heavily piped in by using their full potential. So here RISC processors are going to support this pipeline concept. So here pipelining means execution of instructions will be overlapped in nature. That means in one clock cycle, when the first instruction is fetched, in the next clock cycle it is going for decoding. When the first instruction comes into decoding, the second instruction will be fetched. Okay. So here this RISC architecture supports this pipeline mechanism. Whereas if we go for CISC architecture, it is non-pipelined. So because of this pipeline mechanism, we are going to get high throughput, but by using less power. And next characteristics is simple instructions. So RISC instructions are simple and always consistent. So because of this simplicity, that means since it is having simple instruction set, we have to use more instructions that can be executed in one clock cycle. So in one clock cycle, since the instructions are very simple, more number of instructions can be executed. And the instruction cycle, it is also having fixed length for any instruction in this RISC process. And another characteristics of RISC are it is having simple addressing modes. So addressing modes in RISC are simple and do not use memory references. That means here addressing modes are very simple. And since it consists of more number of general purpose registers, it is not going to use more amount of memory unnecessarily. Uniform fixed length instruction set, next characteristic. And so uniform fixed length instruction set. So here data can be stored in two ways. The two ways are, one can be by using the instruction, that means inside the instruction, and another way is by using registers. Okay, so the data can be stored in the instruction or in the registers. But generally, we are talking about RISC now. So in RISC, data is stored in the registers which are of fixed length. So here all the registers that are available in the RISC, will be of fixed length. Now, coming to the next characteristics of RISC, it is having large number of registers. Okay, more number of registers, general purpose registers are available in the RISC process. So, RISC uses large number of registers to execute the instructions. So, since it is using more number of registers, it can free up the memory. So, it cannot use memory unnecessarily. Maximum they can use the available registers. And so, that is what about some of the features of RISC and architecture of RISC. Next, coming to the CISC processor. So, first, what is meant by CISC? So, here CISC stands for Complex Instruction Set Computer. Okay. So, here the name itself says the instruction set will be somewhat complicated. So, if the instruction set is complicated, though it is complicated, to execute one operation, single instruction can be used instead of using 3 to 4 instructions. But here, since the instruction is complicated, in order to decode that instruction, the compiler has to face problem. And so, in order to execute that complex instructions also, the compiler has to do more work. And to execute that instruction also, one clock cycle is not enough. Clock cycles will be more. So, based on the instruction, the clock cycles will be different. It will not be uniform. Now, we will see some of the features related to this CISC. So, minimize the number of instructions per program. So, since it single instruction we can use to perform that particular operation instead of using more instruction. So, that is why the number of lines or number of instructions to execute one operation in the program, we can use less number of instructions. So, length of the code is relatively short. So, since less number of instructions are used, automatically the length of the size, number of lines present in the program will be less. And next, it ignores the number of cycles per instruction. Why? Because based on the type of instruction, the number of clock cycles will be differing. That is why ignore the number of cycles per instruction. Now, so here the compiler has to convert from high level language to assembly level language or machine code. So, this has to do very little work to translate a high level language into assembly level language or machine code. Next, so RAM is required to store the instructions, because in CISC process we will not have the registers. That is why in order to store the instructions or in order to store the data, we have to use RAM, that is memory. And so, coming to the CISC process, so here are some of the CISC process, that is IBM 370, 168, and next CISC processor is VAX 11, 780 and Intel 80486. These are different processors that comes under CISC category. Now, so coming to the architecture, this is the architecture of CISC processor. So here CISC stands for Complex Instruction Set Computer. So in this CISC architecture, previously we have discussed about the RISC architecture. In the RISC architecture, reduced instruction set computing, here we used to have hardwired control unit. But in this CISC architecture, it is a simple control unit. Okay. So this control unit will access this microprogram control memory. So here in this memory unit is separate. Why? Because in the CISC architecture, we will not have number of registers. So we have to access the memory. So that is why here we have microprogram control memory. So this control unit is going to access this memory and this program and data path. So in this CISC architecture, this instruction and data path both are resided in the same unit. But previously in the RISC architecture, program memory, that is instruction unit, is separate, whereas this data path unit is separate. But here in the CISC architecture, both are resided in the same unit. Okay. So these two will be placed in this cache memory, and this cache memory will be accessed by the main memory. So in the RISC architecture, instruction and data path are resided separately, whereas here in the CISC architecture, both instruction and data, that is program and data, both are resided in the same unit. So this is the main difference between RISC and CISC architecture. Okay. So this is also the difference between Harvard and Von-Neumann architecture. Now, so coming to the characteristics of CISC. So it is having variety of addressing modes. So there in the RISC, only simple addressing modes are there. But here in the CISC, variety of addressing modes are available. So large number of instructions, and so it is having variable length of instruction formats. So whereas in the reduced instruction computing, it is having fixed length instruction formats. But here the instruction formats are variable. And so several cycles are required to execute one instruction. So here based on the instruction, the number of clock cycles will be differing. But there, for one instruction, it requires only one clock cycle. Now, so instruction decoding logic is complex. Why? Because the instruction is complex. That is why in order to decode that instruction, it is very complicated for the compiler. One instruction is required to support multiple addressing modes. Okay. So single instruction is enough to show multiple addressing modes. And so those are some of the characteristics of CISC processor. Now coming to the example of RISC and CISC. So let us consider a simple program here to add two 8-bit numbers. How the operation will be if you go for RISC, that means if you use the reduced instruction set computing, and how the same operation can be performed if you go for CISC architecture. So in order to add two 8-bit numbers, so first we will see how it is going to perform by using this CISC approach. So here CISC stands for complex instruction set computer. As we know, the instruction set is very complicated. That means single instruction can be used to perform that operation. So in order to perform the operation of two 8-bit numbers, so only single instruction like add instruction can be used in order to perform that simple task. Okay. So there will be a single command or instruction to execute this operation. So what is that single command? Simply add. It will be performing this particular task. But we will see the same example how it can be done if we go for RISC approach. So RISC stands for reduced instruction set computer. So in order to write the program, here the instruction set is very simple. So it requires more number of lines. Here, how it is going to require more number of lines means, first what we have to do, first we have to load the command into the registers. Then we have to use the operator like add. After performing the operation, next we will get some result. Taking that result, it has to be stored in the desired location. So in order to execute the same 8-bit number, you have to go for using the commands like load, operator and store. But there in the CISC architecture, simple command, only one command like add. So here the operation is divided into different parts like first load, operate, and store. So these are the three types of commands we have to use if the same program is executed by using this RISC approach. Now, so we have seen different features and characteristics of RISC and CISC, and also we have seen the architecture. So considering all those, now we will see what are the differences between this RISC and CISC architecture. Now, so here CISC stands for Complex Instruction Set Computing and RISC stands for Reduced Instruction Set Computing. So the basic difference first, CISC architecture gives more importance to hardware, whereas RISC architecture gives more importance to software. So CISC architecture, so in this the instructions are very complicated, the instruction set is complicated. In the RISC, the instruction set is very simple, reduced instructions. And so in the CISC, it accesses memory directly because number of registers are less, but whereas in the RISC, it requires registers, general purpose registers. And so in the CISC, coding in CISC processor is simple because direct instructions can be used, operators can be used, whereas in the RISC, coding in RISC processor requires more number of lines because the instruction set is very simple. And so coming to the CISC, as it consists of, it means here CISC. So as it consists of complex instruction set, it takes multiple cycles to execute. So here the number of cycles is irrespective of the instruction. So coming to the RISC, RISC. So it means here RISC. So RISC consists of simple instructions that take single cycle to execute. And so CISC, complexity lies in microprogram, and here complexity lies in a compiler. These are some differences. Coming to the other differences, some more differences. So here in CISC, transistors are used for storing complex instructions. In the RISC, transistors are used for more registers. Now, so CISC, it supports variety of addressing modes. So here what are the variety of addressing modes it can support means register to register, register to memory, and memory to memory data transfer is possible. But coming to the RISC process, it can perform the data transfer only, register to register operations. So register to register transfer only can be done. And so CISC means code size is small. Why? Because we are using less number of instructions. And in the RISC, code size is large. Simple instructions. And the last one is instructions are larger than the size of one word. And coming to the RISC, instruction fit in one word. That means maximum instruction size will be 16-bit. But whereas in the CISC, instruction size may be greater than 16-bit also. So these are some of the differences between the RISC and CISC process. So mainly this RISC and CISC process are developed based on the Von-Neumann architecture and hardware architecture. So here, this is the architecture of Von-Neumann architecture. Now, so here we have the processing unit and here we have the control unit. So which is going to transfer the status and opcode. So main thing here in the Von-Neumann architecture, if you consider this block, the data, program, memory. That means here the data and program will be residing in the same memory. Okay. So in this architecture, program and data both are resided in the same memory. Okay. So here program memory means that is the memory where the code is present, main program is present, and data memory means other than code, the remaining information will be present in the data. So here the program and the data both are present in the same memory. That is why generally if the processor wants to access program or data, it has to search in this entire memory because both are combined. That is why to access the processor takes more amount of time. Okay. So this is the architecture of Von-Neumann architecture. Now, coming to the hardware architecture. So this is the main difference. Okay. So in the Von-Neumann architecture, data and program both are resided in the same memories. But whereas in the hardware architecture, data is separately present in the data memory, whereas program is placed in the program memory. That means here data and program both are residing separately. So what is the main here? Data and program are present in separate memory. Okay. So here what is the main advantage if data and program resides separately means, so in order to access the data, the processor can directly go to the data memory to access the data, and the processor can directly go to this program memory to access the code. So accessing time required for the processor will be less. Okay. So this is the main difference between this hardware architecture and Von-Neumann architecture, that is regarding architecture point of view. So we will see the differences between this hardware architecture and Von-Neumann architecture by considering some features. So here we have, that means hardware architecture consists of separate program memory and data memory, whereas here Von-Neumann architecture consists of common program memory and data memory. So here hardware architecture, execution of instructions are faster because fetching of the code and fetching of the data can be done easily because they are resided separately. But whereas in the Von-Neumann architecture, execution of instructions are slower. Why? Because in this architecture, both program and data are residing in the same memory. In order to access them, it is somewhat difficult. It takes time. And so execution of instruction takes less instruction cycle. And in this Von-Neumann architecture, execution of instruction takes more instruction cycles. And this RISC processor is designed based on this hardware architecture. So that is why in the RISC processor, if we observe, the program and data memory both are separate. Now, here the CISC processor supports Von-Neumann architecture. CISC processors are designed based on the Von-Neumann architecture. So that is why in a CISC process, both program and data will be resided in the same memory. So these are some of the differences. Coming to some more differences here, hardware architecture, it supports parallelism, but whereas Von-Neumann architecture won't supports parallelism. And hardware architecture, chip design is complex because here separate memory is there, program and data are resided separately. And in the Von-Neumann architecture, large advantage is it simplifies the chip design because only one memory is accessed. And so if we consider hardware architecture, general microcontrollers like PIC, all these comes under the all these processors are designed based on the hardware architecture, whereas the processors like Motorola 68HC11, these are designed based on this Von-Neumann architecture. So these are some of the differences between hardware and Von-Neumann architecture. Now, so here advantages of RISC architecture. So some of the advantages of RISC architecture based on the characteristics or based on the architecture. So advantages are, RISC architecture has set of instructions. So high level language compilers can produce more efficient code. And another advantage is, many RISC processors uses the registers for passing arguments and holding the local variables, because in the RISC processors we have more number of general purpose registers. So because of that, the speed of operation can be maximized and the execution time can be minimized. And so very less number of instruction formats, a few number of instructions and a few addressing modes are needed. So those are some of the advantages as per the features, characteristics and architecture. Now coming to the disadvantages of RISC architecture. So some of the disadvantages are, the performance of RISC processors depends on the programmer or compiler, how efficiently they are using the instructions. And so the knowledge of the compiler plays a major role while changing the CISC code to RISC code. And also while rearranging the CISC code to RISC code, it will increase the size. So here, it also, the quality of this code expansion will again depend on the compiler and also on the machine instruction set. So these are some of the disadvantages of RISC. Now coming to the advantages of CISC architecture. So based on the characteristics and architecture of CISC process, advantages of CISC are, microprogramming is easy assembly language to implement and less expensive than hardwiring a control unit. Another advantage is, it is easy for microcoding the new instructions, that is allowed for the designers to make CISC machines that is highly compatible. Now, so another advantage is, as the instruction become more complicated, fewer instructions could be used to implement a given task because the instruction set is very complicated. Those are the advantages of CISC. Coming to the disadvantages of CISC architecture. So the performance of the machine slows down due to the amount of clock taken by the different instructions will be dissimilar. Why? Because in the CISC architecture, to execute any instruction, the clock cycles are not uniform. They will be varying based on the instruction. And here another disadvantage is, only 20% of the existing instructions will be used in a typical programming event, that is during programming, even though there are different types of instructions in the instruction set that are not even used frequently. So among a number of instructions, only fewer instructions are used during programming. So the conditional codes are set by the CISC instruction as a side effect of each instruction, which takes time for this setting. These are the disadvantages of CISC. Now, here are some of the design issues of RISC processor based on the characteristics and architecture. So some of the design issues are, it is having simple addressing modes. So the RISC machine uses simple register addressing having displacement and PC relative modes. That means this RISC can transfer data only between register and register. More complex modes are synthesized in software from the simple ones. And another design issue is simple instruction formats. Generally here, any instruction format will be consisting of two fields. One is opcode field, another one is operand field. So RISC uses simple instruction formats. That will be RISC processor instruction formats will be approximately maximum size it will be word. So generally only one or fewer instruction formats are used. In such machines, the instruction length is fixed and aligned on word boundaries. So in addition, the field location can also be fixed. And another design issue is performance using optimizing compilers. How means? So as the instructions are simple, the compilers can be developed for efficient code organization by maximizing the register utilization. And also even part of the complex instruction can be executed during a compile time. So by doing like this, the performance will be increased for a compilers. And another design issue is high performance of instruction execution. So while mapping of HLL to machine instruction, the compiler relatively uses the simple instructions. So the control unit design is simple and it uses little or some amount of micro instructions so that it can execute simple instructions faster compared to RISC, so that it can achieve high performance by executing the instruction. And simple instructions support better possibilities of using instruction pipelining. So this RISC processor supports this pipelining, whereas CISC is not going to support pipelining. And another design issue is VLSI implementation of control unit. So in the VLSI, implementation of control unit is somewhat complicated. It is a design issue. So a major potential benefits of RISC is VLSI implementation of a microprocessor. Here the VLSI technology has come into existence in order to reduce the delay during transferring of information among the CPU components that is happening in the microprocess. But the delay across chips are higher than delay within chips. That means within the chip, the components that are connected to the chip are making more amount of delay. So VLSI processor is difficult to develop as the designer must perform circuit design, and then we have to go for layout and then modeling the device level. So this is the difficulty in developing the VLSI processor. So all these are some of the design issues of RISC processor. So this is what about the RISC and CISC process. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.